Okay, so I had unit 3.12 and it was complex numbers. A complex number in standard form looks like A plus BI. The A standing for the real part of the number, and the BI is standing for the imaginary part. An imaginary unit is the square root of a negative number. So I is equal to the square root of negative 1. The square root of negative 16. To solve this, you really can't take a square root of a negative number. So you have to use an imaginary number. To get rid of this negative, you put an I on the outside of the radical because this stands for that negative underneath the radical. So it's I square root 16. And the square root of 16 is 4. So our answer is 4i. Same with radical negative 36. We have to put an I outside that radical because you can't take a square root of a negative number. So I radical 36. And we know that the square root of 36 is 6. So our answer is 6i. I squared is equal to negative 1. Anytime you see an I squared, you must substitute it in with a negative 1. For example, 10I squared is equal to 10 times negative 1, which is negative 10. So 10I squared is equal to negative 10. Just like 100I squared, substitute in that negative 1 for the I squared, gets us negative 100. So for quadratic equations, we must solve for our variable, so we have to isolate it. So to isolate this first one, we have to subtract 25 from both sides, which gets us x squared is equal to negative 25. Now to isolate the x, you have to take the square root of the x squared because the square root cancels the squared out. So since we did it to this side, we have to do it to this side. But when solving for a variable and you take the square root of both sides, you must have plus or minus. Which means, since we took the square root of it, it's x is equal to plus or minus the square root of negative 25. And then we have to solve for the square root of negative 25. So we know x is equal to plus or minus I radical 25. And we know the square root of 25 is 5. So that gets us x is equal to plus or minus 5i. And that is our answer. So 2x squared plus 11 is equal to negative 37. We must isolate the variable, subtract 11 from both sides, and this gets us 2x squared is equal to negative 48. We then must subtract 2 from both sides, which gets us x squared is equal to negative 24. Then we must take the square root of both sides to isolate that variable, and we get x is equal to this plus or minus the square root of negative 24. We have to do plus and minus again because we did the square root of both sides. Now, 24 is not a perfect square, so we're just going to simplify that radical. So I radical 24 because there was a negative number. So we got 2 and 12, 6 and 2, and then 3 and 2. So our radical looks like 2 times 2 times 2 times 3. We have a pair of 2's, and that pair of 2's goes on the outside of the radical. But we already we have an I outside the radical as well, so we just multiply the 2. So we get 2i radical, and then we just multiply that 2 and the 3, which gets us the 6. So x is equal to plus or minus 2i the square root of 6. And that is our answer. So for adding with complex numbers, we really just combine like terms. That's all you really do. So we have 6 minus 4i plus 6 plus 4i. So we're going to combine our like terms. We have 6 plus 6, which gets us 12. And we have negative 4i and positive 4i. Those two cancel out, which gives us 12 as that answer. So this one is the same thing. 8 minus I plus 5 plus 4i. We're going to combine those like terms. We're doing that real number first because we're doing it in the complex number. We're doing the complex number in standard form. So we're going to combine those like terms first, which gets us 13. And we're going to do 4i minus I, which gets us the 3i. So plus 3i. And that is our answer. Okay, so for subtracting, we're going to have 6 minus 4i. And then we're just going to distribute this negative right here. So minus 6 minus 4i. Going to combine like terms. 6 minus 6 gives us 0, so those two cancel out. And then we're going to have negative 4 minus 4, which gets us negative 8i. And that's our answer. This one, same thing. 7 minus 6i. Distribute that negative. Minus 3 plus 6i. Then we're going to combine those like terms. 7 minus 3 is 4. Negative 6i plus 6i. Those two cancel out. So 4 is our answer. Okay, so for multiplying complex numbers, we just use the distributive property. So we're just going to distribute this 4i to both of these numbers here. So 4i times negative 6 gets us negative 24i. 4i times I gets us 4i squared. And remember, I squared is always equal to negative 1. Anytime we see an I squared, we substitute that in for a negative 1. So we've got negative 24i plus 4, substitute in that negative 1. So this gets us negative 24i minus 4. This is the correct answer, but we have to put this complex number into standard form. So the correct answer is negative 4 minus 24i. And that is our answer. We just put that real number first. Okay, so for this one, we're doing distributive property as well, but we're doing the first inner outer last, or the FOIL method. So we're going to distribute the 6 first. So 6 times 6 is 36. 6 times 4i is a positive 24i. Then we're going to do this negative 4. We're going to distribute negative 4i times 6 is a negative 4i is negative 24i. Negative 4i times 4i is negative 16i squared. Then I combine these like terms. 24i and negative 24i, those two cancel out. So we're left with 36 minus 16i squared. And we have that I squared again, and I squared is equal to negative 1, so we're going to substitute that in. So we have 36 minus 16 times that negative 1, which gets us a positive 16. So 36 plus 16 gets us 52. And that is our answer. Okay, now we're going to have one more problem with multiplying. So 9 times negative 4 gets us negative 36. And then 9 times 7i is 63i. And then we're going to distribute this 2i. So 2i times negative 4 is negative 8i. So 2i times 7i is a positive 14i squared. So we're going to combine like terms. So 63 minus 8 gives us 55i. So we have negative 36 minus 55i plus 14i squared. So we have that I squared still, so negative 36 minus 55i, I squared is equal to negative 1. Going to substitute that in, 14, negative 1, which gets us negative 36 minus 55i minus 14, because we substituted in that negative 1 for the I squared. So this gets us 50, because we have to combine these like terms. Gets us 50 minus 55i. And that is our answer.